Hi, I'm Lou, K2FP with MeterBuilder. Just wanted to give you a general rundown of some of the MeterBuilder functions with particular emphasis on the user interface. And so we'll go through a few examples, show how a few menus work. And basically the menus work all more or less the same way. So if you understand one or two of them, you should understand all of them. Right now, I want to point out that the MB-1 is working in a simulated mode. We're not running real power through it. The inboard simulator is generating a simulated full-scale value of 2,000 watts, a constant SWR of 3, and the simulator is in what we call the simulator sweep mode, generating a sawtooth wave, which is useful for checking the calibration of the panel meter after you calibrated it. In this particular case, you'd expect to see the forward and reflected needles track the SWR equal 3 curve all the way up. Indulge me for a minute before I explain the menu structure. Just want to change the simulator to something a little bit more realistic that you might see in voice. Right now it's generating random samples from 0 to 2,000 watts, again with a SWR of 3, a constant SWR. Now, to understand how the meter works, let me back this up a little bit and reframe it. The first thing to note is that the various buttons, most of them have multiple functions depending upon the interval they're pushed. They can either be pushed for a short interval, medium interval, or long interval. And if you look at this LED, it will show you, it will flash each time a different interval elapses. Without worrying about the functionality I'm invoking now, that's the short push with 1 flash. That's the medium push with 2 flashes, and 3 flashes indicate that you've reached the long duration. So it makes it pretty straightforward to select the correct interval when you have to use one of the multi-function buttons. To operate MB-1, there are really only 2 simple rules. The first is to select the menu for the item that you want to control. The menu is shown on the 4th line of the LCD, and once the menu is displayed, in this particular case we're showing the bar graph menu. We're now showing the panel meter menu, 7-segment menu. You'll note that there are different fields, and fields are separated with 1 or more dashes. So this would be the first field for the 7-segment display, the second field, the third field. The dash indicates not applicable. And these fields, the values that they represent, are controlled by menu button 1, 2, 3, and 4. And again, it's simply a positional reference between the items on the menu bar and the 4 menu buttons. There are 2 ways to select menus. There's a menu scroll down button that will walk you through all 19 menus. A menu scroll up button. As we've already hinted, the buttons on the bottom are referred to as shortcut buttons. You can think of these as analogous to Windows toolbar buttons. You know, on a Windows program you have a toolbar button that allows you to, with a single click, invoke commonly used functions. Same thing here. If I want to bring up the panel meter menu, 7-segment display menu, min-max menu, coupler menu, and again, with the multiple push, that'll bring up the LCD menu, bar graph menu. You can quickly get to a menu of interest. Not every menu is selectable with a shortcut button, but most of the commonly used functions are. So you can quickly get to a menu, and once you've selected a menu, you're then going to use one of the 4 menu buttons to modify the meter settings. Let's use the 7-segment setup as an example. Right now I'm showing the bar graph menu, A single push of that shortcut button will bring me to the 7-segment display menu. The first field selects which of 4 different LED modules I want to modify. The second field selects the mode or measure parameter that I want displayed on that particular module. The third field is zero suppression on or off, and we'll see that certain measurements look a little bit better with the leading zero suppressed. In this particular case, there is no fourth menu field, so menu button 1, 2, and 3 correspond to controlling these functions respectively. Now we can see the numbering scheme for the 7-segment display is D1, D2, D3, D4. You can see right now that D1 is displaying average. You can see that D2 is off, D3 is off, D4 is off, D5, which is the external display that I'll show you in a minute, is also off. Okay, let's walk through the different measurements that can be displayed on each of the 7-segment displays. Now I'm showing average. Again, with 0 to 2000 watts simulated values, you'd expect the average value to be, you know, somewhere about mid-range, and it's in that general ballpark. Again, the second field corresponding to the second button. I'm showing peak forward now, and peak forward is going to max out at 2000, but again, depending upon the random samples, you'll approach that, not necessarily get there for every measurement. Reflected power, real time. Delivered power, real time. SWR. And here's a case where our SWR looks better with the leading zero suppressed. Each of the leading zero suppression features or bits are independently controlled for each of the modules. So it's, again, you can control these independently for each of the 4 modules. Okay, the panel meter, bar graph full scale, band, coupler, min and max. I'll talk a little bit about min and max, but the other functions, the coupler, bar graph, full scale, those are configuration menus. The coupler is simply the selected coupler. Panel meter is the full scale value of the panel meter when you're running it in auto full scale mode. So the point is that you, in addition to displaying measurements on the 7-segment displays, you can display various configuration information. Okay, I'm now on tune, and this is showing me the real-time forward power, and the next time I hit the button, I'm back to average where we started from. Let me set up the other 7-segment displays. D2, let me set to SWR. D3, let me set to the min function. And we'll talk about that in a minute. D4, I'll set that to the max function. Okay, so right now I'm displaying 4 separate measurements simultaneously, and in fact, let me just pan up to, there's a 5th meter on the top, the external display, that I'm going to set to peak forward. Okay, so you can see right now we're approaching the 2000 watt full scale value for some of the peak measurements. So you have the ability to control up to 2 external 7-segment displays. In this particular case, we have the meter configured for 1 7-segment external display and 1 bar graph. So in this case, you are limited to 1 7-segment external display. But in this case, we have 5 separate measurements being displayed simultaneously. Let's talk a little bit about the min-max function. The min-max function is similar to the min-max function in the Bird 4391A digital watt meter. You specify a parameter of interest that you want the min-max function to process. The min-max function then monitors that parameter and displays the minimum and maximum value over the capture interval that can be reset by the user at any time. Okay, let me bring up the min-max menu. We're not going to worry about these other fields. The first field, corresponding to menu button 1, selects the parameter that we're going to process with min-max. Let me go ahead and reset the min-max value. Okay, right now we're measuring tune, and tune is the nomenclature in MB-1 for instantaneous forward power. Being that we're generating random values from 0 to 2000 watts, we'd expect the min to eventually get down to 0 watts and the max to reach 2000 watts. And you can see we're well on our way there. Again, menu button 1, menu button 2, I can use a menu button to reset the min-max function. And you can see when the function is reset, these two values temporarily are set to the same value. As soon as the next value is processed, it's going to be different, and you'll see these two numbers start to diverge. If your min-max menu is not being shown, an easy way to reset min-max is using one of the shortcut buttons, and it serves the same function. Okay, what else can we measure with min-max? That one we won't define. That's a little involved. It's covered in the manual. Average. MB-1 has a true averaging measurement capability, and as you would expect, average is going to deviate or going to be approximately halfway between the max and min with some deviation. And you can see right now the minimum average value is 569 watts. We've gotten up to 1436 watts. This will never reach 2000. That'll never reach 0, again, because the way the averaging window works. I can measure the min and max of peak. This will reach 2000 watts in the real world. This will reach 0 if I'm talking on if I'm on single sideband and stop talking. Of course, the peak power will go to 0. This is the min and max of the real-time reflected power, and this is a little interesting. We have 2000 watts full scale forward power. We have an SWR of 3, and you can see that our reflected value is approaching 500 watts, and 500 watts is the correct value you would have for when you have an SWR of 3 and a forward power of 2000 watts. Again, let me go ahead and reset it. See if those numbers converge back to that category. And again, you see that they do. Okay. Min-max of real-time delivered. Min-max of SWR, and again, in this particular simulation setup, the SWR is constant, so we're not seeing any deviation. In the real world, you would see any swings on the SWR you would see on the min-max function. Off, and we're back to real-time processing of forward power. So that's a rundown of the min-max feature. Now, we spent a little bit of time setting the meter up, and you don't want to have to go through this each time you power up the meter. MB-1 has 7 configuration sets where you can save the 100+ parameters that are part of the settings of MB-1. If I want to save these settings to the startup set so that they're restored every time the meter is powered up, I've got a save legend in my silk screen there. Simply give this a long press. I see a confirmation message that the settings were saved to the startup set. Let me power cycle the meter. As you recall, the very beginning, this was the only 7-segment display that was illuminated. So, indeed, we have saved the settings. The simulator that was running is always turned off by default when we power up the meter. So let me just go ahead and put the simulator back on. And we're right back to where we were before we powered off the meter. If you're operating the meter and you make some modifications and you want to get back to your power up settings without power cycling the menu, there's a shortcut button for that. Okay, that also restores your startup settings. And again, simulator always turned off whenever you update a configuration set or power cycle a meter. Let me bring up the panel meter menu, and I've got three fields here. First one allows me to select the panel meter in the event or situation where I have some external panel meters hooked up to my MB-1. This allows me to select the parameter that I want to display on the selected panel meter, and this gives me some control if I want to select the manual range. Right now I'm in the auto full scale range. That's indicated by the asterisk. The auto full scale range is toggled on and off with this shortcut button. You can see right now that I'm not in auto range, so if I go ahead with 1, 2, 3, 1, 2, 3, the third menu button, okay, I've selected a manual range of 20 watts, and clearly there's an overrange indication being shown. Actually, two overrange indications. The first overrange indication is the yellow LED on that switch. The second indication is a feature unique to MeterBuilder that we call soft overrange. Rather than just maxing out at the full-scale value for that particular range, soft overrange allows you to define during the calibration of that panel meter how much excursion above the full-scale value you want the meter to go when a overrange is encountered. So you can tell by looking at this that you have an overrange. You don't know exactly what the measurement is, but you do indeed know that you have an overrange. So in any case, let me go ahead and put the auto full scale back on. Okay, and again, now the range is being controlled by the software to make sure that there's no overrange. So we've basically covered the third field in the panel meter menu. Let's see what we can display on the panel meter. Tune, again, is MB-1's nomenclature for instantaneous forward power. In the case of a cross needle meter, the forward and reflected power is being displayed simultaneously. And the intersection of the two needles, of course, indicates the SWR. When I select average, for all of the other readings you're going to see on the panel meter, only the forward needle applies. The reflected needle is used only in the tune mode. So you can see I have some averaging filtering going on there, and you can see that taking place. Peak forward. Again, I'm in the 2000 watt full scale range, and I believe the peak hold is set to 1 or 2 seconds. So you can see based on the random value that the peak value is indeed what we expect it to be. Delivered real-time power, which is forward minus reflected. Min tune, max tune. One of the things you can do with MB-1 that you can't do with some of the other meters, any measurement or parameter that can be measured or calculated can be displayed on any of the measurement devices. So that's why the min and max functions show up on the panel meter as well. And they're also available on the bar graph. We showed them before on the 7-segment display, but they can be used basically on any display device. Okay, I could turn the panel meter off altogether if I want. And right now I'm back to my real-time forward and reflected power reading with the SWR again being shown by the intersection of the two needles. Okay, I had to back off a little bit so that you could see the other external panel meters that we have connected to MB-1. This is an MFJ jumbo meter movement. Again, just a meter movement. And this is a Daiwa meter. We're, again, just using the meter movement section of it, just the forward and reflected needles and coils. So the first option in the panel meter allows me to select my different panel meters in the event I've connected them to MB-1. P1 happens to be the internal meter. P3 in this case is the MFJ meter, and I'm showing real-time power. Again, if I switch over to average, you can see the averaging, and again, all of the same features or measurement types that we showed on the other meter. Let me go ahead and pick the Daiwa meter. I'm not sure you can see the needle there. Let me go ahead and select the real-time mode for forward and reflected power. It's pretty versatile in the respect that if you have a station that's not located next to the meter head, you can locate your panel meter up to 150 feet away from the meter head, and that could come in handy depending upon your particular configuration. The soft overrange that we mentioned before, that's particularly useful if you remote an analog meter away from the control head, because you really won't have visible access to the overrange LED, and having the needle have an excursion beyond the full-scale value can be useful in a situation like that. So that's the rundown on the panel meter. Okay, the last menu that we're going to discuss is the bar graph menu. Let me select the bar graph menu with a shortcut button. 4 fields. The first field allows me to define which device I want the bar graph information displayed on. The LCD is defined as the internal bar graph display. The LED display, the external LED display, is defined as the external display. I can turn both on. I can turn the bar graph completely off. So let me put both bar graphs on. Tune, as we've seen with some of the other menus, allow us to select the parameter we want displayed on the bar graph. Tune is instantaneous forward power. Average is forward power with the averaging filter kicked in, and you can see the averaging filter. Now, right now, I might as well talk about it now. You might notice that at certain points there's a numeric display to the top right. That's what we refer to as the Automax feature. Automax, when enabled, causes the bar graph to assume the maximum value of the currently encountered signal. And if that currently encountered signal increases, as it just did a little bit, the Automax full-scale value will increase, so that you're guaranteed that you'll never go into an overrange. It also guarantees that you will always have maximum resolution. At any point, if you change your power, let's assume you switch from linear operation to barefoot, and you've maxed out at the linear power, you can always reset the bar graph full-scale value. It starts out at 1 watt and then immediately assumes whatever the maximum value is of the current signal. So it's adaptable, it's flexible, and I find it useful to know what the full-scale value of the bar graph is. It's not always obvious on some of the other meters, and that was one of the things we wanted to add to the MB-1. Okay, so we've basically talked about Automax. We'll leave that on. I can display peak forward, reflected, and if the portion of the bar graph is obstructed by the display, I can always force the current full-scale bar graph value with a long push of one of the menu buttons. It's also possible, as we saw before, to configure one or more of the 7-segment LEDs with configuration information. So the value that I have displayed here could just as well be displayed in one of the 7 segment displays as well. Let's continue. Reflected real time, delivered real time, SWR. Okay, I've got an SWR, constant SWR of 3. It turns out that the SWR feature makes use of manual ranges and not the Automax. And we explain why in the manual it didn't quite make sense to do that for SWR. But for all other parameters, the Automax function can be used. Minimum tune, maximum tune. As we mentioned before, the min and max functions can be used on any display device. And what's the maximum value? We expect it to be close to 2,000 watts. Let me force the display. Lo and behold, it is 2,000 watts. Okay, so I'm back in the tune mode. The third field allows me to force a manual range should I want to do that. 20, of course, gives me an overrange condition. So does 50. So does 200. Okay, 2,000 is certainly within range. So you can select manual ranges, and there may be some situations where you don't want the Automax value to vary. Actually, the Automax is going to stabilize. If you have a stable system, it's going to stabilize more or less at the same power level for each session. And one of the advantages of that feature is if it doesn't, your station may not be operating normally, and we'll talk about that when we show a demonstration using MB-1 with real power. Okay, one of the things that I forgot to show with the bar graph was the fourth field, sticky bar. Sticky bar basically holds the maximum value of the bar graph display. It could be turned on or off. And it works with any of the measurement parameters that could be measured with the bar graph. Reflected power, delivered power. And again, it could be turned on and off. There are times when it's useful to have that on. There are times when I find it annoying. So having the ability to turn it on or off and not slave it to a particular measurement, I think is an advantage. So that's the way the sticky bar works. Just wanted to make sure I covered that aspect. We talked about the simulator before, and the simulated values we were using had a constant SWR of 3. Right now we've selected a coupler that's been programmed to generate a variable SWR for each linear sweep, anywhere from 2 to 3. And as we pointed out, the simulator is not just, it certainly was a useful development tool, but it's not just for demonstration purposes. If you calibrate a panel meter, including the external panel meters, in this particular case, we're getting a whole series of SWRs. Each time the sweep starts, 2.51, and you should see the needles sweep for the entire duration of the sweep at that particular value. So this is a useful feature for doing a sanity check on the calibration of your panel meter. So just wanted to show another use of the simulator, and we find quite a few uses for it, both in setting up the meter and also in verifying setup of the couplers and panel meters. You may have noticed in the initial video that the internal panel meter calibration wasn't quite correct. I didn't notice it until I viewed it on the video with the zoom. So we'll just show how we can correct that. Let me zoom out a little bit. At any time you can check the calibration of a panel meter. Simply bring up the panel meter calibration menu, and hit the information menu, and in addition to displaying the various information, it has a test function. And what test does is it cycles through the various calibration points. This meter is calibrated at 2 points in the forward and 2 points in the reflected. And you can see that the 20 watt power isn't quite right. The 2.5 and the 5 in the reflected seem to be in pretty good shape. So let's go into the calibration function and let's select an edit function, and this will walk me through the various calibration points. 10 looks pretty good. That's the one that has to be tweaked a little bit, so I'll use the up button to advance that a little bit, and I'll do a save, walk through the 2 reflected. They look pretty good. I'll save the calibration settings. I can do another quick test. And now the meter should. Let me go ahead and put the sweep back on. And let's see how we do now. That looks pretty good, at least on the viewfinder. But you get the point in terms of calibration. So, thought it was a bad way to start the video off to not have the panel meter calibrated, and we wanted to make amends. Okay, that's it. Not quite as long as a 224-page manual, but maybe the equivalent in terms of a short introductory video to the MB-1. So hope you've gotten some useful information out of this. We'll be following up with a number of other tutorial videos to show, I think we've shown only 5 of the menus. There are 19 menus. We'll show each of the functions of the MB-1 in detail. And if you have any questions, just drop us an email at support@meterbuilder.com. Okay, thanks a lot for dropping by.